The Earth's history.
The geologic timescale is a record of the major events and diversity of life forms present in Earth's history. The geologic timescale began when Earth was formed and goes on until the present. It divides Earth's long history into units of time. Geologic timescale has four major divisions of time. Ions here. Ions are the largest division, followed by eras, then periods, and finally epochs, which are the smallest division of the four. Here they are: aeon, era, period, and epoch. There are two aeons, the Precambrian aeon and the Phanerozoic aeon. But as what you can see in the chart, there are four. But these three right here, the Hadean, Archean, and Proterozoic, these three aeons together are known as Precambrian time because they came before the Cambrian period.
So we're done in Precambrian time. Then let's move on at Phanerozoic. The Phanerozoic has three eras, namely Paleozoic, Mesozoic, and Cenozoic. The Paleozoic has periods, namely Cambrian, Ordovician, Silurian, Devonian, Carboniferous, and Permian. And in Mesozoic, there are three periods, namely Triassic, Jurassic, and Cretaceous.
Now let's move on to Cenozoic. So Cenozoic has two periods. There are Tertiary and Quaternary. And Tertiary has 5 epochs, and that is Paleocene, Eocene, Oligocene, Miocene, and Pliocene. And Quaternary has 2 epochs, and there are Holocene and Pleistocene.
Geologic major events.
The Hadean Aeon occurred 4.6 billion to 4 billion years ago. It is named for the mythological Hades, an allusion to the probable conditions of this time. During Hadean time, the solar system was forming within a cloud of dust and gas known as the solar nebula, which eventually spawned asteroids, comets, moons, and planets. During the Archean Aeon, methane droplets in the air shrouded the young Earth in a global haze. There was no oxygen gas on Earth. Oxygen was only in compounds such as water. Complex chemical reactions in the young oceans transformed carbon-containing molecules into simple, living cells that did not need oxygen to live. The name Proterozoic comes from Greek and means earlier life. One of the most important events of the Proterozoic was the accumulation of oxygen in the Earth's atmosphere. Soft-bodied animals, large enough to be seen by the naked eye, evolved around 900 million years ago and are numerous by 650 million years ago. By roughly 550 million years ago, however, they are scarce, because so little fossil evidence of animals of this age has been discovered. Scientists are not certain whether these earliest animals were wiped out through an extinction event at the end of the era or whether they evolved into the hard-shelled life that follows.
Paleozoic era. It began with the creation of the Earth around 4.6 billion years ago. 5 major events occurred during this era. First, the formation of the sun and light, the creation of the Earth, the creation of the atmosphere through volcanic outgassing, the creation of the oceans, and the creation of life. The events marking in Cambrian period are a large-scale global warming trend. A receding of the Precambrian ice age allowed for warmer, more oxygenated seas. An increased capacity to foster life then arose. In this environment, there was an unimaginable radiation of species. Significant Ordovician events. Beginning in the Ordovician period, a series of plate collisions resulted in Laurentia, Siberia, and Baltica becoming assembled into the continents of Laurasia by the Devonian and Laurasia by the Pennsylvanian. Also see Cambrian period. Possibly the most remarkable biological event during the Silurian was the evolution of diversification of fish. Not only does this time period mark the wide and rapid spread of jawless fish, but also the appearance of both the first known freshwater fish and the first fish with jaws. In Devonian, the development of roots, seeds, leaves, and woody tissues provided the means for species diversification, growth into the large trees, and finally the development of the first forests. Roots improved water and nutrient absorption and the ability of plants to anchor into soil, which also appeared during the Devonian. In Carboniferous, the later half of the period experienced glaciations, low sea level, and mountain building as the continents collided to form Pangaea, a minor marine and terrestrial extinction event. The Carboniferous rainforest collapse occurred at the end of the period caused by climate change. During the Permian period, Earth's crustal plates formed a single, massive continent called Pangaea. In the correspondingly large ocean, Phantalasa, marine organisms such as brachiopods, gastropods, cephalopods, nautiloids, and ammonoids, and crinoids were present. On land, reptiles replaced amphibians in abundance.
The Mesozoic era is the age of dinosaurs. Triassic period. This era is popularly known as the age of reptiles, and for good reasons. Reptiles, and particularly dinosaurs, were the dominant land-dwelling vertebrate animals at that time. The lineage of many modern-day reptiles began in the Triassic period, including crocodiles, lizards, and turtles. On the tectonic side of things, Pangaea began to break apart, a process that continued into the Cenozoic era. The Triassic ended with the world's fourth, but not last mass extinction. The Jurassic period was a golden time for dinosaurs, which flourished for 180 million years. Huge sauropod herbivores and carnivores emerged. However, carnivorous dinosaurs also diversified during the Jurassic. Moreover, the oldest known fossil of a bird is from the Jurassic. During the Cretaceous period, the first flowering plants appeared and rapidly diversified. Also, the Rocky Mountains began to rise from the Cretaceous interior seaway. However, the event that has caught the public's imagination is the mass extinction that marks the end of one era with dinosaurs and begins another without them. Current thinking holds that 66 million years ago, a large asteroid crashed into Earth near the Yucatan Peninsula of Mexico and caused the most famous, though not the most extensive, mass extinction.
Cenozoic, age of mammals, 65.5 million years ago to present day. Tertiary, Paleocene, 65.5 million years ago, first large mammals appear. Eocene, 57.8 million years ago. Eocene, Oligocene extinctions event. Oligocene, 36.6 million years ago, mammals are dominant. Miocene, 23.7 million years ago, grass become widespread. Paleocene, 5.3 million years ago, hominids or human ancestors appear. Quaternary, Pleistocene, 1.6 million years ago, earliest humans appear. Ice Age begins. Holocene, 0.01 million years ago. Today, Ice Age ends. Humans are dominant.